Welcome to our deep dive into projectile motion and its crucial role in forensic investigations. Projectile motion refers to the curved path an object takes when launched, influenced only by gravity and not by air resistance. In the world of forensic science, understanding this concept is essential for reconstructing crime scenes involving bullets, thrown weapons, falling bodies, or even blood spatter. By applying projectile motion equations, investigators can determine launch velocities, flight times, and impact speeds, which are vital for distinguishing between different types of incidents such as suicide, accident, homicide, or staged events. Let's explore how these calculations bring clarity to complex cases. Projectile motion isn't just a physics concept. It's a forensic tool that helps experts reconstruct what really happened at a crime scene. By analyzing the path of a bullet or a thrown object, investigators can compare their findings with witness statements, autopsy results, or video footage. This scientific approach allows them to challenge or confirm stories, ensuring that justice is served based on facts, not speculation. The ability to calculate and verify these trajectories is what makes forensic evidence so powerful in courtrooms. Projectile motion is broken down into two independent components, horizontal and vertical. The horizontal component involves constant velocity, meaning the object moves at the same speed throughout its flight. The vertical component, on the other hand, is affected by gravity, causing the object to accelerate downward at 9.8 meters per second squared. By analyzing these two components separately, forensic experts can reconstruct the entire path of a projectile with remarkable accuracy. Simplify the math. Forensic scientists make several key assumptions when applying projectile motion equations. They assume a flat Earth with constant gravity, ignore air resistance, and consider the effects of rotation or spin to be negligible. Additionally, they work with known launch and landing heights. These assumptions allow for straightforward calculations, but experts are always aware of their limitations and adjust their conclusions accordingly. Horizontal component of projectile motion is governed by simple equations. Since there's no acceleration, the velocity remains constant. The main equations used are hmax equals vx times t and x equals xi plus vx times t, where hmax or x represent the total horizontal displacement. These formulas help investigators determine the range or muzzle velocity of a projectile based on measured distance and time, providing crucial data for crime scene reconstruction. Vertical motion is a bit more complex due to the constant acceleration caused by gravity. Several equations relate height, time, and velocities under free-fall conditions. These include formulas like if equals u plus 1/2, v plus vfyt, vfy equals v minus gt, if equals u plus v minus 1/2 gt2, and vfy2 v2 minus 2g, if minus y. By applying these equations, forensic experts can determine how long an object was in the air, how fast it was moving when it hit the ground, and more. Forensic experts know that their calculations must withstand scrutiny in court. That's why they always verify their results using at least two different equations. This cross-checking process ensures that the findings are reliable and can be confidently presented as evidence. By demonstrating consistency across multiple methods, experts build a strong foundation for their conclusions, making it difficult for opposing counsel to challenge their work. Let's walk through a real forensic example involving a bullet fired horizontally from a building window. The initial height is 19.6 meters, and the bullet lands 58.8 meters away. By applying the vertical motion equation, investigators first solve for the time of flight, finding it to be 2 seconds. Next, they use the horizontal equation to calculate the muzzle velocity, which comes out to 29.4 meters per second. This step-by-step approach reveals critical details about the shooting. To determine how long the bullet was in the air, experts use the equation if equals u plus v minus 1/2 gt2. Plugging in the values, they find that the bullet's flight time is 2 seconds. This calculation is crucial because it sets the stage for determining both the horizontal velocity and the impact speed, which are key pieces of evidence in reconstructing the shooting scenario. With the time of flight known, the next step is to calculate the bullet's horizontal velocity, also known as muzzle velocity. Using the equation x equals xi plus vx times t, investigators find that the muzzle velocity is 29.4 meters per second. This value is compared to typical firearm speeds to determine what kind of weapon was used and how far the shooter was from the target. The final vertical velocity at impact is determined using vfy equals v minus gt. In this case, the bullet's vertical velocity upon hitting the ground is minus 19.6 meters per second, indicating a downward motion. This information helps experts understand the force of impact and can be used to match physical evidence at the scene, such as bullet holes or damage patterns. To ensure accuracy, investigators verify their results using the average velocity equation, if equals u plus 1/2 v plus vfyt. The numbers match perfectly, confirming the calculations are correct. This cross-verification is a standard practice in forensic science, providing confidence that the reconstructed scenario is reliable and scientifically sound. Another way to verify the findings is by using the time-independent equation, vfy2 equals v2 minus 2g, if minus y. When the calculated values are plugged in, both sides of the equation match, further confirming the accuracy of the reconstruction. This thorough approach leaves little room for doubt in court. The calculated muzzle velocity of 29.4 meters per second is typical for a handgun but unusually slow for a rifle. If a suspect claims a long-range shot, these numbers prove otherwise. The short flight time and low speed indicate the shooter was close, supporting a homicide charge rather than an accidental distant discharge. This is how physics helps uncover the truth. Now, let's examine a case where a weapon, such as a knife, is thrown during an assault. The weapon is thrown from ground level and lands 60 meters away after 5 seconds. By analyzing both the horizontal and vertical components, investigators can determine the strength and intent behind the throw, which is critical for legal outcomes. The first step is to calculate the horizontal velocity using x equals vx times t with a distance of 60 meters and a time of 5 seconds. The horizontal velocity comes out to 12 meters per second. This value gives insight into how forcefully the weapon was thrown, which can be compared to typical human capabilities. Next, investigators use the vertical displacement equation to find the initial vertical velocity. Plugging in the numbers, they determine the vertical velocity to be 24.5 meters per second upward. This calculation is essential for understanding the launch angle and the overall trajectory of the weapon. At the end of its flight, the weapon's vertical velocity is calculated using vfy equals v minus gt. The result is minus 24.5 meters per second, indicating a downward motion at impact. This information helps reconstruct the weapon's path and assess the potential for injury or damage. To confirm the calculations, the average velocity equation is used again, if equals u plus 1/2 v plus vfyt. The numbers align perfectly, demonstrating the reliability of the findings. This step is crucial for building a strong forensic case. The time-independent equation, vfy2 equals v2 minus 2g, if minus y, is used once more. Both sides of the equation match, confirming the accuracy of the reconstruction. This thorough approach ensures that the evidence stands up in court. The calculations reveal that the weapon was thrown with a total speed of about 27.4 meters per second at a 64-degree angle. This requires significant strength and deliberate aim, ruling out an accidental drop. The 5-second flight over 60 meters proves intent to strike from a distance, supporting charges of assault or attempted murder. Projectile motion principles are also applied in bloodstain pattern analysis. When blood droplets are projected, they follow predictable paths. By calculating the impact angle and velocity, forensic experts can determine the location of the attacker and reconstruct the sequence of events. This technique is invaluable for solving violent crimes. In cases where a pedestrian is struck by a vehicle, the person is treated as a projectile. By analyzing the distance the pedestrian is thrown and the time in the air, investigators can estimate the vehicle's speed at the moment of impact. This information is crucial for determining fault and reconstructing accident scenes. Projectile motion calculations can reveal when a scene has been staged. For example, if the calculated horizontal velocity is impossibly high for a fall from a low window, investigators may reclassify the case as a homicide rather than a suicide. This scientific approach helps ensure that justice is served and that no detail is overlooked. While projectile motion equations are powerful, they have limitations. Real-world factors like air resistance, wind, bullet spin, Magnus effect, and uneven ground can introduce errors of up to 10–20%. Forensic reports always include uncertainty ranges and recommend using ballistic software for more accurate validation. To improve accuracy, forensic experts often use specialized ballistic software, such as Ballistics Explorer. These programs account for real-world variables and provide more precise calculations. By combining traditional equations with advanced technology, investigators can present even stronger evidence in court. In the courtroom, forensic experts present their calculations step by step, using every relevant equation. This transparent approach allows judges and juries to follow the logic and see how the conclusions were reached. The ability to cross-check results with multiple methods makes the evidence nearly unassailable. Cross-checking results using different equations is a hallmark of forensic projectile analysis. This process not only ensures accuracy, but also builds credibility in the eyes of the court. When multiple methods yield the same answer, it's hard to dispute the findings. In many cases, the entire scenario unfolds in just a few seconds, the flight time of the projectile. Yet, within those seconds, forensic experts can extract a wealth of information that can prove or disprove a suspect's story. This rapid analysis is one of the reasons why projectile motion is such a powerful tool in investigations. Projectile motion bridges the gap between physics and the pursuit of justice. By applying scientific principles to real-world scenarios, forensic experts can uncover the truth behind complex events. This intersection of science and law is what makes forensic investigations both challenging and rewarding. When forensic experts testify in court, they must clearly explain their methods and findings. By breaking down each calculation and showing how the results were verified, they help judges and juries understand the science behind the evidence. This clarity is essential for ensuring fair verdicts. The journey from a crime scene to the courtroom involves meticulous analysis and careful documentation. Every measurement, calculation, and verification step is recorded to build a comprehensive case file. This attention to detail ensures that the evidence can withstand legal scrutiny and support a just outcome. No scientific analysis is without uncertainty. Forensic reports always include uncertainty ranges to account for real-world variables. By acknowledging these limitations, experts provide a more honest and accurate picture of what likely happened, strengthening the credibility of their findings. Modern forensic labs often rely on ballistic software to simulate projectile motion under various conditions. These programs can model air resistance, wind, and other factors that affect a projectile's path. By using such tools, investigators can refine their analyses and present more robust evidence in court. One limitation of basic projectile equations is that they ignore the Magnus effect, which is caused by bullet spin. This effect can alter the trajectory, especially over long distances. Forensic experts must consider these factors when analyzing cases involving rifles or other spinning projectiles. Real crime scenes are rarely perfect. Uneven ground, obstacles, and environmental factors can all affect projectile motion. Forensic experts must account for these variables and include them in their uncertainty estimates, ensuring that their conclusions remain valid even in less than ideal conditions. Thorough documentation is essential in forensic investigations. Every calculation, assumption, and verification step must be recorded. This meticulous approach ensures that the evidence can be reviewed, replicated, and defended in court, making it a cornerstone of forensic science. Becoming proficient in projectile motion analysis requires rigorous training. Forensic experts must master both the underlying physics and the practical application of equations. Ongoing education and hands-on experience are vital for maintaining high standards in the field. Forensic investigations often require collaboration between experts in different fields. Ballistics specialists, medical examiners, and crime scene analysts work together to piece together the puzzle. This teamwork ensures that all aspects of the case are considered and that the final conclusions are as accurate as possible. The field of forensic science is always evolving. New research, improved technology, and updated methodologies help experts refine their techniques. By staying current, forensic professionals can provide the most reliable and up-to-date evidence in court. Ethical considerations are paramount in forensic science. Experts must present their findings honestly, acknowledging any uncertainties or limitations. This commitment to integrity ensures that the pursuit of justice remains fair and unbiased. Forensic evidence based on projectile motion can be the deciding factor in many cases. By providing clear, scientific explanations for what happened, experts help ensure that the right verdict is reached. This impact underscores the importance of rigorous analysis and transparent reporting. In summary, projectile motion is a powerful tool in forensic investigations. By applying physics to real-world scenarios, experts can reconstruct events, verify stories, and support the pursuit of justice. The combination of scientific rigor and ethical responsibility makes forensic analysis a cornerstone of modern law enforcement. As technology advances, the tools and techniques used in forensic projectile analysis will continue to improve. From enhanced software to new methods of data collection, the future holds exciting possibilities for even more accurate and reliable investigations. Staying at the forefront of these developments is essential for all forensic professionals. Thank you for joining us on this exploration of projectile motion in forensic investigation. By understanding the science behind the evidence, we gain a deeper appreciation for the meticulous work that goes into solving crimes and ensuring justice. The next time you hear about a case involving bullets, thrown weapons, or mysterious falls, you'll know just how much science is at play behind the scenes.